Hello, today we will discuss harmonic bundles. This is the concrete example of the cross ratio when this fraction equals 1. So we need to show that xb over xc equals bf over fc. To show this, we need to use two theorems. One is about Chebyshev theorem. So this tells us that bf over fc multiplied by ce over ea, then multiplied by AD over DB equals 1. Now, for the second one, we need to use the Mendelau's theorem. In this case, the intersectional line must be XDE line, and ABC must be our triangle. So we will get that XB over XC multiplied by AD over DB and multiplied by CE over EA. This equals 1. Now if you look at these terms, BF over FC and XB over XC, this is the only different terms in both equations, so this means that they must be equal to each other. So this was what we wanted to prove, and by using the property of perspectivity of cross ratio, we can show that if we take the point, instead of B, if we take point D, instead of F, we take point K, and instead of C, E, we get that XD over XC must be equal dk over KE. This is pencil property, which we have discussed in the previous video. If you don't know about this, you can look at this video, or if you don't know any of these videos about Chebyshev or Mendelau's, you can visit my playlist. Next one is about the angle bisector. If we are given internal angle bisector and external angle bisector, then these 4 points will give us 4 harmonic points. Like, we need to show that BD over DC must be equal FB over FC. Now we will use the ratio of the angles, which we have discussed in the previous video. So this equals that sine of alpha over sine of alpha must be equal sine of 90 minus alpha over sine of 90 plus alpha. If we assign this as alpha 1, alpha 2, and alpha 3, as we have done in the previous video, because we know that sine of beta equals sine of 180 minus beta, clearly both of these fractions equal 1. And this was what we wanted to prove. And last one is about the Symmedian. It's well known that 4 points A, B, C, and D will give us harmonic points if they are on the Symmedian, if P is on the Symmedian of ADC angle. You can prove this very easily, that AB times CD equals AD times BC. You can either use law of sine or some Symmedian facts. And now we need to show that points D, Q, B, P will be also harmonic. And to show this, we need to take A as the perspectivity point, and if we reflect these 4 points, like look at this one, from A we look at triangle points D, B, AC, and we will get D will remain into its place. We are reflecting on L line. D will go to D, B will remain to its place, A will go to the intersection of AA to the line L, and this means that tangent from AA means the tangent from A, and this must be point P, and then C must go to the intersection of AC and L line, and this is point Q. So we will show that DQBP must be also collinear, not collinear, harmonic bundles. These 4 points will make harmonic points. So this was all I wanted to discuss for today. If you want to discuss some harmonic configurations, please write in the comments.